Hello there and welcome to a brand new lesson. Now, I do hope you are doing well. In this video, you are looking at the real number system. The real number system contains every measurable number on the number line. And our goal is to understand the very basic building blocks of the system. So without much I say, let's quickly look into it. So we'll start first of all with what we call the natural numbers. The natural numbers. What are natural numbers? The natural numbers are the counting numbers we use to first learn what numbers are. Okay, so they are the numbers we use to count. And note, they are all positive whole numbers starting from 1. You see, so just as I said, the numbers we use to count. If you want to count something out, you don't start from 0, but then you say 1, 2, 3, 4, and it goes on and on and on. Okay, so natural numbers are numbers we use to count. They are all positive, and then they start from 1, 2, 3, and then it goes on and on. The next one, talking of the whole numbers, this set includes all the natural numbers plus 0. Take note, we just spoke of natural numbers, but then the whole numbers would then include all the natural numbers plus what? 0. So they are also non-negative, but then they start from 0. So we say 0, 1, 2, 3, 4, and it goes on and on. Now, if this is what we are saying, then it simply means every natural number is a whole number, but not all the whole numbers are natural numbers, because 0 is not a natural number. You see, so you take note of the relationship between whole numbers and natural numbers. Then as we proceed, you see we are building the real number system. So let me give you the note on the whole numbers. Now, as you can see, we have said this includes what? The natural numbers plus 0. You see, the 0 here. Now, they are all non-negative whole numbers. We'll talk about negative numbers very soon. So if you are talking of their sets, then it includes 0, 1, 2, 3, and it goes on and on and on. This is its relationship with the whole numbers. So we say that what? The natural numbers, which is n, is a subset of whole numbers, which is w. What this means is everything in n is contained in w. You see, they are all members of whole numbers. Let's look at the third set of numbers, and we call them integers. We call them integers. So the integers will be the last set of numbers we'll talk about. I'll give a visual representation, and then we solve some questions. Integers. So this is the set that includes the whole numbers and their negative counterpart. Its symbol is Z, this letter Z over here. You see, and then the Z is actually a German word, which is Zahlen. Zahlen simply means numbers. That is very interesting to note. So what are the characteristics of the integers? Any whole number at all you can think about, whether positive or negative, including the 0, they all form part of the integers. You see, but take note, fractions and decimals are not part. You see, so any number without a fraction or decimal is an integer, whether positive or negative. And they are set. So as you can see, we have a 0 here in the middle, and then we can have from 1 to 3 all the way to infinity. And they are negative counterpart as well. All these form integers. So what then will it say is the relationship between integers and then what? Whole numbers. All whole numbers are subset of integers. You see, so basically, these are the foundations or the foundational set we need to build the real number system. We'll look at more in our subsequent videos later. So all we are actually saying with this visual representation here is that what we have n, that is our natural numbers. Okay, the natural numbers which we have them here are in the whole numbers. I hope you see that. So they are all in the whole numbers over here. And all these natural numbers and whole numbers are also in the integers. You see? So they are forming what? A system where would all together get what we call the real numbers. So this is the visual representation. Let's solve some questions. So for our very first question here, it says classify the following numbers into all possible sets. We have to classify them to all possible sets. So let's look at our solution. Starting with the 12. The number 12 here, you realize that 12 is a natural number. So it is a natural number. It is also a whole number. It is a whole number. And then 12 is also an integer. You see, so 12 belongs to all the three sets we have considered so far. Let's take negative 4. Negative 4 is not a natural number. Why? Because we don't use negative 4 to count. You see, and negative 4 is also not a whole number, because the whole numbers, we said they are positive. Remember the characteristics we considered. They are positive. But is negative 4 an integer? Yes, it is. So it is an integer. Look at 0. 0, on the other hand, is not a natural number because we don't use it to count. Is it a whole number? Yes, it is a whole number. Is it an integer? Yes, because the integers are what? Both positive and negative, including 0. Now, what of 8 over 4? You don't be in a haste to justify your inclusion or exclusion. 8 over 4, if simplified, would actually become 2. Take note. 8 divided by 4 gives us 2. You see? So 8 over 4 is actually 2. Then we ask ourselves, is 2 a natural number? Yes, it is a natural number. Is it a whole number? Yes, it is a whole number. And is it an integer? It is an integer. You see? Then we look at 3.0. 3.0 is also just 3. You see? Later on, we'll be looking at decimals and all that. But this 3.0 here is actually the same as 3. So is 3 a natural number? It is a natural number. Is it a whole number? Yes, it is. And it is also an integer. You see? So these are the possible sets these numbers belong to. Okay? So let's look at the next question. It says, which is the smallest possible subset that contains the result of the following operation? We have 10 minus 15 plus root 1. So what it is actually asking us to solve this operation, or this we have here, and then we tell what or which of the sets we can find this answer. Let's quickly look at how we are going to solve it. So we have 10 minus 15, then plus root of 1. Now, you know root of 1 is still 1. So we have 10 minus 15 and then plus 1. 10 minus 15 gives us a negative 5. So we have negative 5 plus 1. A negative 5 plus 1 gives us a negative 4. We are done with the operation. Now, to what set does it belong? Negative 4, we know, is actually an element of what? The set of integers. You see, because it is not a whole number. Take note, because it's a negative number. Negative numbers are not whole numbers. It is also not a natural number because we don't use it to count. You see, so these are some basic questions you can get on what we've done so far. Let's solve one last question, after which I'll give you some exercises for you to try on your own to test your understanding. So our last question here says we should list the numbers from this set. So in this set, we have -5, -1, 0, 0.5, 9, and 10. That belongs to the set of integers, but do not belong to the set of whole numbers. You see? So let's look at our solution. In our set, we have -5, we have -1, we have 0, 0.5, 9, and then 10. Okay, so our first condition is that it must belong to the set of integers. So looking at those from this set that belongs to the set of integers, we have -5. -5 is an integer. The -1 is also an integer. 0 is 0.5 is not an integer. So we don't include that. But then we include our 9 and then the 10. But the second condition says it should belong to the set of integers, but not to the set of whole numbers. Hence, we now want to cancel out those that are actually whole numbers. You see? So with that, you realize that 0 is going to be cancelled. 9 is also going out, and 10 is also going out. So our answer, that is the set we actually need, is going to be what? The set that contains -5 and then -1. And this is the solution to the answer, the question above. So this is how far this video is going to get. Now I'll give you some questions you can try just to test your hands on. So these are just 4 questions you can try on your own to test your understanding. If there's anything you don't understand, you can always let me know at the comment section, and I'll do my best to explain it. Let's have Beyond Numbers, where we learn maths the easy way. Now, if this is your first time on this channel, you can always choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. Stay blessed and see you in our next lesson. Bye for now.